Hi, this is Pavan from KINDUZ Business Consulting. We will go through the measure phase of the DMAIC cycle of Lean Six Sigma. This is the part 4 of 8 of the entire Introduction to Lean Six Sigma series. As you would have seen in the past 3 sessions, you can access all these videos at our KINDUZ Consulting Network, which is at kinduz.ning.com. You have here a network of some of the senior experts from the industry. Once you log in and register yourself with the KINDUZ Consulting Network, you can network with them. You will be able to post questions, get answers, access all the videos, and also download the presentations of the Introduction to Lean Six Sigma course. What we have covered till now is an overview of Lean Six Sigma, some perspectives of Lean Six Sigma, as well as the define phase. What we're going to cover today is the measure phase. Now, if you look at the inputs that come into the measure phase, these are all the outputs of the define phase, which is basically you are having identified the right team, having identified who the critical customers are, what their requirements are, after having created a process map and identified some quick win opportunities for yourself. What you do in the measure phase is to determine what to measure. So for example, you might have defined a business initiative or a business goal that you want to achieve in a very subjective way, for example, growing the sales. And what you do in the measure phase is identify where you stand today and where you exactly want to go. So that you define the business goal or how much you want to solve a business problem in a more objective way. It might not be necessary that you have all the measurements and data available right at the start of an initiative. So there might be cases where you might have to come to the measure phase, define all the measures, find out where you stand today, and then go back and redefine your problem statement in a more objective way. If you already have data and you've already defined your business problem or a business the initiative goal in a very objective way, what you still might want to do is to evaluate the current measurement system, ensure that there is a homogeneity in the measurement system, ensure that if you measure the data vis-a-vis somebody else, the values that you get is the same for a certain set of processes that are followed in a particular way. What you also do out here is understand the current capability of the system and determine the process performance. So overall, the measure phase is for determining what to measure, how do you manage the data collection system, develop and validate the measurement system, and determine the current process performance. So which is what is also defined out here, where we're saying is one, you determine what to measure, and in most of the cases it is to measure what the customer wants you to measure. If the customer wants you to measure defect density instead of just defects, that's what you measure. Obviously you also measure the defects along with it, but the goal is to identify what the customer wants you to measure. The second step is to manage the measurement system, which is basically who measures this data, when do they measure the data, how frequently would they measure the data, what is the sample size, and things like that. Once you determine what to measure and define and manage your measurement system, obviously you start collecting data. And once you start collecting data, you also get to understand what is the current variation in the system, whether you're getting your credit card bills on time, or whether they are three days before or 3 days after, or 6 days before or 6 days after. That's the variation that you start measuring, and one of the formulas that you use to measure variation is the standard deviation. In the introductory course, we're not going to go through any formulas, which is what is covered in your yellow belt program or a green belt program or a white or a black belt program. So just want to set the expectations right out here. Once you understand the current variation, you also evaluate the measurement system and see whether there is repeatability, whether there is proper repeatability, which is if person A measures an item once, and then the same person measures the same output from the same process once again, is he able to repeat the actual measurement? I mean, the measurement needs to be same. So that's the repeatability analysis. The reproducibility analysis is where person A measures a certain process and gets a certain output, whereas and let's say there's a person B who's measuring the same process. I mean, he or she should be able to get the same measurement because everything is the same. But if the reproducibility is not there, it probably means that the way the person A and person B are measuring and are calculating the actual metric might not be the same. So there's no reproducibility. So what you do when you're evaluating a measurement system is to check whether the measurements you're taking are both repeatable as well as reproducible. Once you have all this data, when you know that your measurement system is good, when you know that you're getting your measures right and you understand the variation, what you then do is to understand what your current capability of the process, of the business process. So at this point of time, you will be able to tell that, okay, this is my business process, let's say recruitment, or let's say production of aircraft engines, or let's say delivery of software code is at a capability level of either 3 sigma or 2 sigma or 4 sigma or whatever sigma that is. So that's what you do in the measurement phase. Now once you know that your current measurement or the capability of your business process is at a certain performance level, let's say 3 sigma, then you can set a goal for yourself and say that, okay, I'm going to take it to a 4 sigma capability level or a 5 sigma capability level, depending upon your competence level, depending upon what the business requirements are and how many resources are actually invested to make that improvement. So what are the key deliverables that you get out of the whole measurement phase? One, you definitely get to understand what are the input, process, output indicators, which is what are the indicators that define the input that is going into a process. What are the indicators that define the process? What are the indicators that define the output, and especially in terms of measurements. So if you take the function, if you take this equation, which is y is equal to f of x, where y is a function of various x's, so which is x1 or x2, x3. Let's take an example. Let's say the quality of steel that is produced is dependent upon the quality of the raw material, the quality of the blast furnace, quality of the amount of oxygen that is put into the blast furnace, the temperature of the blast furnace. So what you have is, if there's a certain unit that measures the quality of iron or steel that is produced, there are a lot of factors that will define what this output is, which is the various x's that are involved. So your x1 could be percentage of oxygen present in the blast furnace, x2 could be your temperature of the blast furnace, of temperature within the blast furnace. X3 could be the quality of iron ore that is put into the blast furnace. For example, what's the percentage of iron that is present per ton of ore that's put into the blast furnace. So there are these x's that collectively define the output, which is what you call as the y. And then once you have these identified and measured, what you also do is define the operational definitions of each of the measure. What is an operational definition is what we'll go through in the next slide. It's basically a definition of for each measurement or a metric, how do you gather the data, who gathered this data, when do they gather the data, what is the sample size, etc., etc., etc. What you also have as a deliverable is the data collection formats and the sampling plans. Data collection format could be using an ERP system, it could be using an Excel sheet, it could be using a piece of paper where you note down data points. Sampling plans basically mean that if you have let's say 1 million credit card bills that are delivered per month, if you start measuring all the 1 million credit card bills, it's going to cost you money to put in that effort. But what you probably would do is say that, hey, what, I will do a sampling plan, and which is basically saying that I'm going to look at a small sample, let's say 1,000 or 10,000 credit card bills, and check the delivery time to make inferences about the entire population of 1 million bills that are delivered to my customers. And generally the recommended sample size is a minimum of square root of the entire set of population. So if you have 100, if 100 is the entire population, then you should have a minimum sample of square root of 100, which is about 10. Now the minimum number that is generally recommended for a statistical analysis for you to start making inferences is 15, but ideally it needs to be a minimum of 30. So if you have 100 as a population, I would strongly recommend for good data points to have at least 30 items. If you have 10,000 data points, you should look at square root of 10,000 as the sample size. And obviously at the end of it, you obviously gauge the measurement system capability, you baseline your current performance metrics, the current data that you have, and what you also have right now is you start to build a more productive team atmosphere to lead a certain initiative. The reason this happens is because once you have data, your entire team knows where you stand. And let's say you might just realize after all these calculations that look, there's no problems at all, and things might just be perception issues that you might have. And these are things that I have seen in a lot of cases where actually one of our clients said that the productivity of the work is not good, and when we started to measure the data and we realized that we're much better than the benchmarks in the industry, and we went back to the client and told them that, look, this is where the industry stands, this is where we are, and we're much better off than the industry. And the client said, great, this is exactly what I wanted, I'm very happy you guys did this analysis. So sometimes it's just a question of there's no problem on the ground, it's just that it's a perception issue which needs to be managed. So the second situation might be where you might think that there is a certain amount of a problem, or let's say you might think that this 40% of the credit card receipts or credit card bills that are being delivered late to the customers. But when you might actually do an analysis, you might realize that, hey, the problem is only for 20% of them, and then that kind of motivates the team and says, yeah, we're much better off than what we thought we were. There might be another scenario where you might realize that you might realize that this 60% is what the problem is. 60% of my bills or receipts are being delivered late, whereas you might have thought it's just 40% earlier. Now that's also good for the team, is because you can go back to your superiors, your bosses, and tell them that, look, hey, earlier we thought it was 40% and you were looking to reduce that failure rate from 40% to, let's say, 10%, but based on our calculations the failure rate is actually 60%. So it might not be possible for us to make such a drastic improvement from in the first improvement cycle. You'll still find that it's very important that you set the right expectations and to negotiate with your superiors to get the resources you need, get the kind of results that they are expecting you to get. So it helps you negotiate with your superiors in terms of the kind of resources you need vis-a-vis. Just to summarize what we've discussed: one, we identify measures, goal, which is the customer satisfaction and what the customers are looking for, and obviously all the variables and goals that you're looking for. So you identify all these measures, you define operational measure, and you measure them. You create a measurement plan. And what you then do is you display and evaluate the data that you have. Say, okay, this is where my capability, and this is where this is what is going to be my cost of 6 months while I take up an initiative and drive through it. What's a measurement plan? And a lot of this is also form a part of the operation. In the measurement plan, you have things like my operational definition. How basically talks about what's the formula that I'm going to use, where am I, source and location, what's the sample size, talks about who will collect the data, when will, how will the data be collected, should there be any other data that need to be collected at the same time if there's some kind of an interaction that happens. You might think in this data, how will data be used? Sometimes because example of defect, and a lot of organizations, the number of defects or up with the variable pay associates. Generally find that people do not share this kind of data unless you have a very good automated mechanism. Some of the cultural issues within an organization that might impact obviously how will the data be displayed using a bar graph, is it a line chart, is it a control chart, how is it going to be? And obviously the reason this is important is because once you have data, people evaluate it and then make key decisions from it. So in the measure phase, the key aspect is to measure data, and there are two kinds of data. One is the continuous data. In the continuous data, the examples of the weight of a person, it can go to 92. That's continuous data. The other data is productivity, is your kilometers of gas, kilometers per liter, so on and so on. Is an attribute data. It's nothing but data as a yes or a no, or do you agree with this kind of information, and then you sum to 5, and where you just have 1, 2, 3, 4, 5, and that you find it as a part of your customer satisfaction survey. There are different kinds of charts that are used to measure each kind of data. A lot of times we hear people say, hey, you know what, my customer satisfaction score is 4 out of 5. Actually, that's wrong. That's a very wrong way to represent that's something that is explained in the measure. And there are different kinds of charts for different kinds of data, are showcased here, are used for that. So it's X bar, although we're not going to go into details of that. but videos on how you can create and use the charts using TEP in the near future. And we did talk about the population that's there, where let's say you have in a total of 1 million credit card bills, and obviously you can't deliver all of them. So what you do is you take a small sample, you take right sample, a small sample, you of number of bills that you will measure the data that you have. You then create control charts or perform. Based on the outputs of the statistics, you make an inference for the sample, and you also put. So that's a sampling plan that you define. Obviously, the kinds of sampling, like the random sampling strategy, and those are things that are also taught in the measure phase. Is segmentation, measurement system analysis for attribute. You have the GRR. This is where you also pick up Minitab as one of the sum of statistics. You taught what standard deviation, mean, median, mode. You taught PES, control charts, and others. So that's the measure about the use of a segment to analyze problems. A lot of times is doing segmentation of the data that you might be having. So it's our hotel chain in the world, and then complaints about customer action, especially in the 5-star hotels. So there's somebody like me, Six Sigma project, and then he starts to look at it in a subjective way that the issue is customer dissatisfaction through some service and everything all over the world, and then they see that a dip of about let's say 2%. So when they want to improve the a lot of times what people make the mistake of is to across the entire hotel chain. An intelligent person would say, let's do a segmentation. Is the issue with hotels in France, or is the issue with hotels in India, or the US, or Canada, or is it the problem with the male, with the female, or is it a problem? And once you start doing the segmentation, a lot of times you actually that there are issues with customer satisfaction, and that too it's not with the male customers, it's for the female customers. And for data through segmentation of the various demographic profile, like why is it that the female visitors or guests from India are not having any problem when the Australian having certain issues or getting dissatisfied with this day. Especially you start to compare things, and then you get a lot of answers there and there, and 70 to 80% of your project right in the measure phase itself. So segmentation is a very that needs to be carefully thought out, because problems out there in the industry, even without going through statistical analysis or a huge amount of the other phases of analysis, improve control, or talking to people. So that was about the so what we've covered till now is we've got an overview of Lean Six Sigma. We've talked about certain perspectives. We have defined a problem statement in the define phase. Hopefully if you phase objective way right in the define phase, but if you didn't have data, you would define the problem state subjective way, come to the measure phase, measure the data, where I stand today, this is where I want to go tomorrow once this initiative is complete. You also say that you also define your measurement system, will make it more reproducible, so that it's more sustainable. Apples and apples and not apples and oranges. In the next 3 videos, analyze, improve, and control phases. And once we have them up and running, we will once these presentations are done, we will then start how you use Minitab as a software to issue in a Lean Six Sigma course. Okay, thanks a lot for patronage. We'll see you again. Have a good day, have fun.